Okay, here we go. So we are on lesson 6, and we're going to talk about parallel and perpendicular lines. And I'm just going to skip the first little thing. We're going to go right to the investigation. It says, no, I'm going to skip all that. I'm just going to skip that. I'm going to go right to page 539, but I'm going to have you tell me, what do you suppose, could you draw two lines that were parallel? What would that mean? What are parallel lines?
Lines right next to each other.
They go side by side. And okay, so let me draw. Like, are you a really good drawer? I mean, so I have this. Okay. So I have this line over here. And if I do this line with this, is it with that? Are those parallel? No, because why? No, it doesn't matter about length. Because what, Malachi?
They go a bit closer.
They get a bit closer, and eventually they'll do what?
Cross.
They'll cross, right. Any two lines that cross aren't parallel, you got it? So in regards to slope, what do you think would be true about parallel lines? Would they kind of have the same slant, like the same slope? Parallel lines will always have the same slope, which makes sense. If they're not ever going to cross, they have to be moving at the same rate as they go up and over. Okay, slope is steepness. All right, so two lines are parallel if they have the same slope. Circle it, underline it, bold it. That's what you know if the lines are parallel, they will have the same slope. Now, perpendicular, if I drew a line like this and I said draw one perpendicular, how would you draw it? How would I draw a line perpendicular to this? Someone takes a pen and come draw a line perpendicular. Anybody know? Perpendicular means what? Two options. One is parallel. We talked about that. They have the same slope. What does perpendicular look like?
Would the line go like this?
Yeah, it will go exactly up and down like this, right? And this would make a 90. Agreed? That's what perpendicular means. It means 90 degrees. So you would have two lines crossing totally opposite directions. So if one went up 1 over 2, up 1 over 2 and looked like this, the other one would have to go down 2 over 1, down 2 over 1, and go this way. That makes sense to you? So perpendicular lines have totally opposite slopes. So I'm going to say it right here. If one slope was 2/3, to be perpendicular, the slope would have to be -3 over 2. It has to be going the other direction. If this one is positive, this one has to come in negative. Agreed? And vice versa. So I'll erase all of this stuff here that I've done. So I'll just say it one more time. To be perpendicular, if you're watching, if you're on the video, you can't see what I'm doing with my hands, but to be perpendicular, if one line is going this way, is that a positive slope or a negative slope? Positive. So you know the other one to be perpendicular has to come in and be negative, right? It has to be. So if one of the slopes is positive, then to be perpendicular, the other slope has to be negative. And the other cool thing that will happen is they will be reciprocals of each other. So if one is up 2 over 3, the other one will be up 3 over 2. Actually, go down 3 over 2. Okay, let's go check it out. Okay, it says consider the slope, the line segment AC with a slope of 3/4. Write the slope of a line segment GH, which is parallel to AC. So parallel means what? They don't ever cross, they're going at the same steepness, which is the same slope. So if this line has a slope of 3/4 and you want yours to have the same slope, it's going to be 3/4. That's all there is to it. It's nothing mind-blowing. They have the same slope if they're parallel. If it was perpendicular, it would be negative, and you would flip it over. Oh, no, but it's the negative reciprocal. It's totally opposite. It's going in the other direction with a totally opposite slope, okay? Because they're perpendicular to each other. All right, so let's talk about that. The slopes of two lines are given. Determine if the lines are parallel, perpendicular, or neither. So how about a slope of 1/4 and a slope of 3/12? Are those parallel? So parallel would mean the same. Perpendicular would mean they're totally opposite, so negative and flipped over. or they could be neither. So I heard a yes. How do you know they're parallel? They don't look the same.
Because if you reduce 3/12, so it's the same slope.
Oh yeah, make sure you reduce before you start. Now, are they the same slope?
Yes.
Yes, so they're parallel. Write the word parallel. They're parallel, same slope. So make sure you reduce those fractions before you start. So the next one, 5/7 and 14/10. Let's reduce. So this is going to be 7/5. Do those look parallel to you? Are they the same? No. Are they perpendicular?
No.
What is missing?
Negative.
There's no negative signs. When they have perpendicular lines, Victor, one of them has to be negative. Because one slope is going up and one slope is coming down.
Yeah.
So these are neither. You with me? Ben, you got it? Now, do you want me to show you on a grid paper? Okay, I'm just gonna, on the video, you won't be able to see this. I'm gonna quickly show them that this is true. We're gonna do just a quick investigation. So if I'm gonna do this, then I think I can do this and do this. Cool, huh? Here's my grid. And if I chose, let's make an axis here. Okay, let's start at the point 1 and 2. Okay? Give me a slope. Give me a slope. Quick.
1/5. Yeah, 1/5.
Sorry, I like yours better. -2 over what? Okay, let's do, okay, the one slope she said was -2 over 3. So from this point, I'm going to go down to 1, 2, and over 3. 1, 2, 3. I'll do it again just so I have a good line. Down 2 and over 3. Okay, now I'm really good at this. Ha! I missed it. That's okay. We'll pretend. Okay? All right. So if I wanted to draw a line perpendicular to that, what would I have to do? What would your other slope have to be?
3/3.
3 over 2. Let's see if it'll look like it's perpendicular. So from the point 1, 2, I'm going to go up 3 over 2. Uh-oh, out of room. Could I do this one? Just go this way?
Yep.
Okay, so I take my point.
That's
Does
cheating.
it look perpendicular?
That's not parallel.
No, they're not parallel. The slopes are opposite, which means they're,
Oh,
do you see how they look perpendicular?
it's both these.
Yeah?
Yep.
Everybody in favor? Okay. So I'm gonna go back. I'll get rid of this. All right, let's do question class example number 3. So just kind of proving to you how that looks like that when you do that. Okay, if P is the 0.47 and Q is the 0.6 -2, find the slope of the line segment that is parallel to PQ. Parallel, what does that mean? Same slope. Do you know what the key to this is? Find the slope over and over and over again. Go find the slope. So let's find the slope of PQ.
Just do 1 x y.
So we're gonna go, so as soon as I see parallel, I'm thinking slope. What slope, Joey?
The line.
Yeah, it's the steepness of a line. How do I find it?
Y minus y over x minus x.
How do I find slope then? Y minus y over x minus x. Every time I say slope, you're gonna think y minus y over x minus x. It's the rises going up and down over the runs, okay? So I'm gonna ask you again in a minute. I'm gonna see if you remember. Okay, so now I just have to name, you know what is a really good thing to do, Victor? Super good to name these x and y's before you ever start. Because some kids get confused. So Joey, above those points, I want you to write x and y. Okay, we're in class example number 3. Super important to name the points.
What are my fingers? It's cool.
It happens to my ears sometimes. This ear will be hot and bright red, and this ear is like white. Okay. All right. Gotcha. Did you label your x and y's? Like I just told you. Do what I told you to. Hurry up. Okay, so now you'll keep track. I'm going to go 7 minus a minus 2. Agreed? And 4 minus 6. Yeah? So I get 7 plus 2 is 9. And 4 take away 6?
Negative.
Negative 2. That is the slope of PQ. Do I need the same slope if I want a line to be parallel? Or do I need the opposite slope?
Opposite.
To be parallel?
Same.
Think about that.
That's perfect.
Parallel. Parallel is the same, that's what I want. If I want perpendicular to that line, what do I want to write down?
That would be difference.
2/9.
2 over 9, is it positive or negative?
Negative.
Negative.
No, that one's already negative.
Positive.
One will be negative and one will be positive. They have to be, right? One's going uphill and one's going down, it'll be perpendicular. You have an X, people, like this. Look, this is positive, this one's negative. You have to have one positive and one negative. Yes? Okay. Got it yet? Okay, turn the page. Triangle LMN has coordinates LMN. Use slopes to show that the triangle is right angled at L. Okay, we gotta draw a little picture. Here we go. Draw me some axes on your page. And then I'm gonna switch colors. And I'm gonna use, actually, what would be really cool? Here, we'll do this. I got this, we can do this. Magic. It even tells me like when I'm 0 degrees off center. Okay, and then I need to plot my point L. So we're just gonna roughly do this. -4, 2. Okay, ready?
Yeah.
-4, 2. I think I'll just do it. Right there. This is L. M is -2 and 7. And N is 1, 0. Okay, draw your triangle. And it says use slopes to show that the triangle is right angled at L. If it was right angled at L, wouldn't that mean something? What would you have to know or show? How could you show something was right angles? What does it mean to be right angled?
90 degrees.
90 degrees, which means perpendicular. Oh, so I need LM, the slope of LM, to be perpendicular to the slope of LN. Agreed? So who cares about MN? Don't even do that one. So if you draw a good picture, you only have to do this twice. As soon as you find the word slope, start using it. How do you find slope, Ben?
X over X?
Nope.
I'm sorry, X.
Nope.
X.
Nope.
Y
Y minus Y.
over X.
There you go. Okay, so I'm going to find the slope of LM. I'm going to find the slope of LM. How do we start that, Joey? What would you do?
You,
This is LM.
okay. So you would take, for the bottom it'd be 7.
Now wait, we didn't label. Wait, we didn't label. You're about to get confused. You should go before you do anything and label your X and Y. So which one is X and which one is Y on the L point?
Well, the first one's always that.
Okay. So now we can fill in. We won't be confused.
7 minus.
There you go. Perfect. Over.
-2 minus 4.
Excellent work.
Go plus.
Well done, Joey. Good job. Okay. So you know what helped us right there? Write this down on your page, sir. You know what helped us? Labeling the points, X and Y. Labeling the point just saved confusion. We were about to be confused. We labeled the points, right, Cece?
Yeah.
Okay, 7 minus 2 is 5. Turn that into a plus. -2 plus 4? 2. That's the slope of that one. LM is the slope of 5 halves. Is it a positive slope? Do I expect LM to be a positive slope?
Yes.
Yes, it looks
Yes.
positive, uphill. Okay, good. Everything matches. My picture and my algebra needs to match. Okay, now I need to do LN.
That's gonna be negative. Right?
-2.
I hope it's negative. If it's not negative, I did something wrong. So how do I find the slope of LN, Ben?
Okay, 1 second.
Slope
It's
is,
gonna be negative. So
what's the formula for slope?
Y, take away Y over X over X.
Okay, now go up here and label your X and Y. So I'm doing with L and N. This is X and Y. So I'm doing this point and this point. Do you understand, people, that 30% of math is being neat and orderly and labeling things properly? Right? That's 30% of the problem. Right? So just getting it done. Okay, so what do you want to try again? 2 minus 0, thank you. And
-4 minus 1.
right on. I get 2 over -5. Are you glad? Is that what you wanted? Have I now shown you got -2 over +5? Perfectly fine. Did you just get what he just said? You got -2 over +5. Same thing. Means one negative sign doesn't matter where it is. All right. Is that what you wanted to happen?
Yes.
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 So you would have to write a little sentence. So how do I know that it's right angled? Write a sentence.
Oh, it is right angled.
It is right angled because why?
Because the slope of LM and LN is.
Abby, be quiet. Because the slopes are perpendicular. No, the slopes are,
Opposite.
yes. The word is negative reciprocal. Ugh, out of space. Negative reciprocals. That's the word you're looking for. What you want to show, because negative means opposite sign, and reciprocal means flipped over, right? So it is right angled because the slopes are negative reciprocals. Understood? Okay. All right. Next, we're almost done. You can get to work. Last question. Every time I say slope, what do you say?
Y minus y equals 10%.
Y minus y over x minus x. Joey, every time I say slope, what are you going to say to me?
Y minus y over. Or
Y minus
over
y
x.
equals 10%. For a couple of math Fridays.
Okay. 2 lines have a slope of -3/4 and k over 5. What's with the k? It always happens. It's what we always do. Right? You think you're doing great when they throw a k in there. It says find the value of k if the lines are parallel. Okay. Parallel lines, what do you know?
Same slope.
The same slope. So do you mean to tell me that -3 over 4 would have to be equal to k over 5?
Got it.
Isn't that true?
Yes.
Okay, solve for k. Go now. Do. Go on your paper. Tend to the work.
Okay.
Well, I have free time, right? Fractions are fun. Leave your answers as fractions. Do you have a fraction as an answer?
Yeah.
It's good. Leave it as a fraction. I like it. So does somebody have, do you know what to do, Ben?
Yeah, figure it out.
Okay. Should we do flippity and see who gets to answer? Joey,
Wait.
do you have an answer? Oh, question? Okay.
Cross multiply.
Yeah, you do. So when you cross multiply, the first thing you want to do is write down an equal sign.
Yeah.
And then you go 4 times k on one side,
So it's 4k.
and 5 times a -3 on the other side. And divide by 4, and it's some funky fraction, which is just fine. Okay? Done deal. Do y'all get that?
Yeah.
Okay, excellent. That's the value of k if these were going to be negative reciprocal. I mean, something the same. Sorry, parallel means the same. Okay, what would perpendicular mean? What would k over 5 have to be equal to if it was going to be perpendicular? The same as -3/4?
No.
Reciprocal.
Oh, the negative. Oh, it would have to be positive 4/3. Do you agree? Do you see that? How I just did that? That's all the differences. If they're parallel, they're exactly the same, and if they're perpendicular, one is flipped over a negative. You could have flipped over the k over 5 part. Doesn't matter. Flip one over, make it the opposite. Okay. So what is this going to equal? We have 3k equals 20. So k has to equal 20 over 3. Agreed? Done deal. That's the value of k that has to be perpendicular. So perpendicular, think, flip it over, make it opposite sign, which is called negative reciprocal. Perpendicular slopes will have to be the negative reciprocals of each other. Parallel will be the same. That makes sense. Going at the same steepness, they can't ever cross. Okay, you have some homework to do. What's the first question on your list? Does anybody know?
3.
Okay, you can do this. Okay, begin.